Alright, so ship P is 144 kilometers west of ship Q. So that's Q and that's P. Ship P is traveling in a direction of 20 kilometers an hour. Oh, good God, they gave us bad numbers. That wasn't nice. Alright, so north 50 degrees east. So we're going north, and then we're going 50 degrees east. So to me, that is the same as, if that's 50, that's 40. Right, so I'm just going to treat it like that. I always tend to work upwards, so that's northeast, and that's 20. So that's what's it? 20 cos 40 and 20 sine 40. Okay, and I suppose 20 cos 40, 15.32. So 15.32 I plus 20 sine 40. 12.856 I'll use. Happy days, right? And that's velocity of P. Now we're going to do Q now, and Q is going the directions 30 degrees north, 30 degrees west. So here's north, and then we have a small little 30 degrees west there. Okay, so that's 30, which in turn will make that 60, and that will be 12. So that'll be 12 cos 60 and 12 sine 60. Now cos is negative because it's going to the left, so 12 cos 60 is 6, so minus 6i, and then 12 sine 60, which would be a decimal. 6 root 3 might be more accurate, to be fair. I'll just use 6 root 3. And that's your phi q. Okay, first question. Find the magnitude and direction of the velocity of P relative to Q. So it wants phi P Q. Velocity of P relative to Q, which is phi P minus phi Q. So phi P is our 15 plus 32i plus my 12.85j, and then we're taking away minus 6i plus 6 root 3j. Alright, so we're going to add the 15 to the 6 to get 21.32i, and then we're going to do our 12.856, take away 6 root 3, and I get 2.46. So I think I'm safe with 2.46 now. Okay, now that is going in a direction, northeast. That's 21.32. That is 2.46, and it says it wants the magnitude and direction. Alright, so I can probably find the angle quite quickly. Tan inverse that. Shift tan inverse 2.46 divided by 21.32, 6.58 degrees. So x equals 6.58 degrees, which is west 6.58 degrees north. Oh, sorry, east. East 6.58 degrees north. Its magnitude will be Pythagoras' theorem. So Pythagoras' theorem will be 2.46 squared plus 21.32 squared. Square root the answer, and you get 21.46. Is it kilometers per hour? Kilometers per hour. Okay, so we've established a lot of good information there. Now we're going to go back to the diagram. I think I only need the information I have now. And here's what we're going to do. Because we did phi PQ, this means that Q is stuck to the spot. Okay, and we're going to find the shortest distance between the ships. Now, we all know that it goes up at, we know the angle it goes up at. P moves relative to Q in a northeast direction. We've established that earlier. So it moves relative to Q at a northeasterly direction. The northeast direction is 6.58. And we want the shortest distance, D. So, opposite over hypotenuse is sine. So sine 6.58 equals D over 144. D on its own is 144 sine 6.58. And what we get there is 16.5. So D is 16.5 meters. 16.5, 501, 16.501. 501 is the nearest meter, not kilometer. 16.501 kilometers. So if I multiply that by 1,000, I get 16,501 meters. Now I'm slightly off the, I didn't round off I suppose, and my angle was slightly different, but that I should be entitled to full marks doing that. Okay, 16,501. The length of time for which the ships are within 60 kilometers of each other, correct the nearest minute. Now, this question is a very good one. And it has a lot to do with the last question. 16.501. Okay, now the 16.501, here's what we're going to do. Okay, so if you imagine P is currently 144 meters from 144 kilometers from Q. Now, as P moves along, it gets closer and closer to Q. Eventually, it reaches a point where it's a distance of 60 kilometers away from Q, as shown. It then travels further distance, come on, there we go, until it's 16.5 kilometers away from Q, and then it travels the same distance out the other side, and then once again it's 60 meters from Q. Now, if I can find out the distance here, this yellow distance here, that's what I'm looking to find, and we're going to use Pythagoras' theorem to find that. So I can find out half the yellow distance by using Pythagoras' theorem. So Pythagoras' theorem will be 60 squared, we'll just call it x for argument's sake, and the distance I'm looking for is 2x. So it's going to be 60 squared equals 16.501 squared plus x squared. Now 60 squared, take away our 16.501. 0.501 squared equals 3327716,999. Oh god, 33. Here. Try and leave as many decimals as you can. This number here, and that equals x squared. Now I'm going to square root that answer. 57.686. 57,686. 57. Is it 868 or 668? 6. Now, if I square root that, oh sorry, I've already square rooted it. Now, that is the distance from here to here, but I need to double that. So I'm going to double down, multiply by 2. And I'm going to say that 2x equals 115.373. 115.373. Now, this is a relative distance, and it needs to be divided by the relative speed. And I can't remember what I said the relative speed was earlier. Either way, it's 115.373. I'm going to find out where the speed was from earlier. I had it a minute ago. There it is there, 21. 115.373. And we're going to divide that by, that's kilometers. And we're going to divide that by 21.46. 6, and we get an answer of 5.36 hours. 5.376 HR is our time, because this time equals distance divided by speed. And then if we change that using the degrees minutes function, it's 5 hours and 22 minutes and 34 seconds, which is 5 hours and 23 minutes, rounded off to the nearest. That's it, rounded off. Okay, good job. Took 12 minutes.